Good morning, everyone. This is Dan Morgan. Welcome to the third series of webinars. I'm in Minneapolis, Minnesota, where its current time is 7 o'clock on Sunday night. And don't envy you because I still have a few more hours of my weekend. But anyway, what I want to do is, on this third one, talk about infrastructure as code. And infrastructure as code as it relates to Oracle's bare metal cloud, and very specifically with respect to Oracle DBAs, and why Oracle DBAs need to start paying attention to a lot of changes that are taking place in our industry. And we're beginning to see a little bit of it right now, but the ball is rolling, and we are going to reach a critical mass probably in the next 2 to 3 years, when the things that you can start doing now will have a major impact on your careers as well as the organizations you work for. So with that as a preface, let's go to the next slide. This is my Unsafe Harbor. All the Oracle employees have to put up a safe harbor statement. I have never worked for Oracle, don't work for Oracle now, and therefore I have an unsafe harbor because I don't talk about things that I don't have substantial experience on. I don't talk about things that are Oracle's roadmap, and I don't talk about things that are not released product or capabilities that you can utilize today in order to improve your career, improve the applications and the databases that you work with, and improve the quality of service of the organizations that you're with. Let's go to the introduction slide that says Daniel Morgan on the top. I'm one of the Oracle ACE Director alumni. I was an Oracle ACE Director, one of the very first ones. And for many, many years, I've now left the ACE organization, but am an alumni now. My background includes a substantial amount of time teaching Oracle, starting with writing the curriculum at the University of Washington and being the university's primary Oracle and SQL instructor for 10 years. I've also guest lectured at a number of universities over the years, including the University of Canterbury, where I did a guest lecture. I believe it was 2012. I could be wrong about that. Let's go to the next slide. This is the homepage of my personal website. A lot of code examples, a lot of things related to Oracle 12.2 are on here. If you look on the upper left side under resources, there's a link called library that will take you to one of the largest resources in terms of Oracle working examples anywhere on the internet. I don't have a lot of things up there right now with respect to the material I'll be talking about today, but that will be coming probably right about the end of the year. The next couple of slides, slides 6, 7, are about the company that I work for, which it looks like may be sold in the next week. So I'll talk about it now for just a brief second. I haven't brought it up in the past, but it looks like we're about to be a $3.5 billion consulting organization focusing a lot on Oracle, a lot on the web, and I'm looking forward to being purchased. I haven't been purchased in a lot of years. So let's go on to slide numbers 9, 10, 11, 12, 13. Most of my personal practice, just so you have a sense of what I normally work on in my day-to-day career, a lot of stability, a lot of IT firefighting, a lot of full stack security, meaning not just the security of the database, but the security of entire applications from the ground up. Scalability, very large databases and partitioning. My largest database to date was 1.25 petabytes for a very large telephone company. And I can tell you that petabytes are so different from terabytes. It was truly an amazing experience. If you haven't gone there yet, you can pretty much throw out everything that you thought you knew about performance tuning. It changes dramatically. A lot of performance tuning work, a lot of work with Golden Gate for zero downtime migrations, And finally, and more closely related to what we're going to talk about today, what I call just-in-time IT procurement, which is really the best way to look at infrastructure as code and the best way to look at the Oracle Cloud. So that's what we're going to work on tonight, or for you this morning. This particular presentation is broken up into 4 separate pieces. And in the first piece, which I call Tone Deaf, on slide 15, I'm going to criticize Oracle Corporation because Oracle desperately deserves the criticism for something. And I've had a couple of Oracle employees just almost lose it when I started this. So if there are any Oracle employees listening, please, you don't need to take your heart medication. It'll all work out okay. But I am a little bit brutal here. So let's go to 16. And I want to answer the question of why I'm starting off by criticizing Oracle. And the reason is that there are a lot of good reasons for Oracle DBAs to be actively, aggressively saying to their organizations, we need to get to the Oracle Cloud as fast as we possibly can. The reason that they're not doing it, the reason why I expect almost everyone in this webinar is not gone to their management and said, are you crazy? We've got to get to the Oracle Cloud, is because Oracle has been decidedly tone deaf. Oracle has completely, totally miscommunicated its message and taken something that we should be aggressively embracing and scared pretty much everyone I can think of into thinking that if they did go to the Oracle Cloud, they might as well just go and start learning how to make lattes or say, do you want fries with that? So let's go to slide 17. Let me show you some of the tone deafness of Oracle and why it's necessary to call them on it. This is Larry Ellison at Open World 2016. And I've highlighted in the middle of his slide the phrase fully managed by Oracle. And he's talking about the Oracle Exadata Express Cloud service. And the problem is that he never defined, and I'm not criticizing Larry here because Larry had his talking points and he did an extremely good job. And if you were listening to his words, it probably wouldn't have bothered you because what he said made a lot of sense. But the slide scared a lot of people because the slide never explains and Larry never explained what does fully managed by Oracle mean, because it doesn't mean what 99% of the people on the planet would expect that it would mean. Let's go to slide 18. This slide is the worst of the worst. Week before Open World, I was at an ACE director briefing in Redwood Shores, and this gentleman was explaining to the ACE directors, of which probably 50-70% of them are Oracle DBAs or people definitely heavily involved in Oracle database. And he had a bullet point on his slide that said, managed by Oracle, no customer DBA required. And I took one look at that thing and I looked at my peers around the room and I thought to myself, this is fabulous. This guy's actually got the nerve to walk into a room full of DBAs and tell us that he and his compatriots at Oracle are going to make us all unemployed. That takes a tremendous amount of courage to do. And I think 90% of the people in the room just turned him off and went back to looking at their iPads or texting people. But let's go to slide 19. Now I want to talk about the difference between the slides that I just showed you from Oracle and reality. Reality is that in the United States, at least, taxi drivers and truck drivers and a lot of other people really are going to lose their jobs to technology. Some of them are doing it already. Some of them, you don't have to look very far down the road to see the fact that their companies are really working hard to make them unemployed. And I can't imagine what it would be like to work for a company that's spending money to try to make you unemployed. That wouldn't feel very good. But DBAs don't have to worry about that. And here's why. Let's go take a look at slide 20. Let's look at the phrase fully managed by Oracle. Keep in mind that Oracle's cloud is sold in a fixed price subscription. You buy a certain amount of CPU, you pay a certain amount of money. Or you store a certain amount of bytes, you pay a certain amount of money. Or you do a certain amount of I/O, and you pay a certain amount of money. So keeping in mind that for a certain number of CPUs, let's say 16 CPUs, you would pay a certain amount of money to Oracle, and it's a flat rate. It's published on the internet. Is Oracle going to rack and stack their hardware in their data center? Of course, it's their data center. It's their hardware. Are they going to provide all the network connectivity, configure the firewall, NTP, DNS? Of course. Are they taking care of the security for their data centers? I would hope so. And they're going to take care of installing and patching operating systems and databases if you were to do platform as a service, database as a service. If you were doing a subscription to bare metal cloud or infrastructure as a service, certainly they would not. But the question, when we come back to whether DBAs are going to become unemployed, is let's look at the stuff that Oracle is absolutely never going to do for a fixed price subscription. And in fact, never going to do, period. Is Oracle going to install your applications for you? Not a chance. They're doing a fixed price based on CPU. Suppose you have an application that gets patched once a month. Suppose you've got people doing DevOps and Agile, and they're releasing code once a week. Is Oracle going to, for some people, be doing a whole bunch of application installs and for other people not, and charging them the same amount? And where's Oracle going to come up with all the DBAs and all the people to try to deal with installing apps and when they don't even know anything about those apps? It's never going to happen. Are they going to create users on demand? You call up Oracle, you open an SR and say, hi, we just hired 12 more people last week. We need for you to go in and create those users, put them into LDAP, and oh, by the way, could you also grant these 3 people these privileges and these 6 people these other privileges? Never, ever going to happen. And you can go through the list of the rest of these things, like tuning bad SQL statements. Oracle is not tuning some people's bad SQL statements for a fixed price. So the very concept of fully managed by Oracle is nonsense. And the very concept of customer DBAs not required is insanity. Why those things slip through onto those slides, I cannot explain, but clearly it's absolutely not true. Let's go to slide 21. Part of the reason is that Oracle has always favored DBAs. It's always focused on DBAs. DBAs have been at the core of everything Oracle has done, whether it's database, whether it's Oracle applications like eBusiness Suite, ages ago, Oracle Financials, Oracle Forms, Oracle Reports. Everything that Oracle has done has pretty much centered on the database. The DBAs have always been the center of Oracle's universe, and it's not changing just because we've got this thing called the cloud. So I'm going to go ahead and skip slides 22, but I do want to stop for a second on slide 23, because part of the other message that I want to remind everybody of, and being that I've been with Oracle now as a user and person who's been deploying and consulting with Oracle for well over 30 years, I've got a bit of a historical perspective, and I have watched through my career that every time Oracle has released a substantial enhancement, I can personally look in the mirror and say, I have done this, and so have most of my peers. We have complained bitterly about what Oracle was doing. And then later on, we thought, boy, were we stupid, this thing is great. So I remember when Oracle didn't even have a rollback segment. Then Oracle introduced rollback segments. Then later on, Oracle replaced rollback segments in rollback table spaces with undo table spaces. We all said, oh, no way, this is never going to be something that you can be automated. This is really complex. Well, there's not one of us that would go back to rollback segments today, even though, even in 12.2, you can, in fact, if you want to, and of course you're stark raving mad, go back and build your own rollback table space and your own rollback segments. It's just called manual rollback or manual undo. But nobody in their right mind would ever do that. Same thing about Oracle Enterprise Manager. I don't know of anybody who'd give up OEM today. But yet when OEM first came out with tuning in it, people were going, oh, well, that's the end of my job. I don't have a job anymore. When Oracle introduced ASM, I heard all the screaming and yelling from the people who were into Veritas and had to have raw disk or had to have a file system. And we saw the same thing very recently in terms of my career recently, when Oracle released engineered systems like Exadata. And yet today, I don't know of a single person who would gladly give up their Exadata and go back to some 3U or 4U server. So we've got to be careful that every time Oracle comes out with a substantial improvement to our technology, and that's what I think the bare metal cloud and infrastructure as code is, that we're not panicking going, oh my God, we're all going to be unemployed. It is going to require that we learn new skills, but it's not the end of the world. So let's go ahead and skip slide 24. I'm just keeping an eye on the clock here. And go to slide 25. And this next section is specifically to address something that DBAs don't often get to hear and see. Oracle technologists don't often see. And that is the message that we're giving your management, because I do a lot of pre-sales. And so what I'm going to do now is not so much oriented to you, but to let you understand the reason why I say that in the next 2 to 3 years, this is going to become completely overwhelming and an irresistible force, and why, knowing that this isn't going to cost you your job, you need to understand why your management is going to jump on this thing. And they're going to jump on it as fast as they can figure out how to do so without putting your organizations at risk. And the name of this presentation is QoS and TCO, which stands for Quality of Service and Total Cost of Ownership. So on slide 26, I break down what is QoS. When we talk about quality of service, we're talking about, is my database and my application stable? Is it secure? Is it scalable? Now, I don't worry about performance when I talk to management, because management doesn't really care about performance in the normal sense of the word. What they want to know is, will it scale? If we've got 100 customers today and we're going to have 500 customers next month, will it handle those 500 customers? They just sort of assume that the performance is the performance, whatever that acceptable margin is. They're more concerned about, does it scale? And of course, does it meet the business needs? From the standpoint of total cost of ownership, nothing's changed in the last couple of thousand years. They're not interested in things that cost so much money that they can't make a profit or that they can't stay within their budget. Let's go to slide 27. I want to give you a quick history lesson here, and again, sort of based on the fact that I'm really old, although not as old as Henry Ford and the Model T in 1908. We in technology have been really puffed up a little bit about how we're the cutting edge, how we're moving ahead and everyone else is trying to catch up with us. But there is one area where we are hopelessly behind, and that's what we're in the process of rectifying right now. When Henry Ford developed the Model T and the concept of production lines, what he came up with was a faster, more efficient way of producing materials. And there was a big gap until about 1977, when primarily out of Japan, we had concepts called just-in-time delivery, continual process improvements, lean manufacturing. And the concept was that you don't go out and buy a one-year supply of aluminum because you're a company that makes jet airplanes. You try to get the aluminum shipped in just before you actually need it for your manufacturing. So if you have to do some quality control on the aluminum, you figure, okay, well, it takes us 2 days to test it. So if we get it shipped in a week or two before, that gives us time to test it. If it's a bad batch, we'll send it back and get another one. But essentially to not be holding massive inventory. The problem that we have in IT has been gradually addressed. When I got into Oracle, there were about 92 separate operating systems and platforms that Oracle supported. We're now down to 4: Linux, Windows, AIX, Solaris. And I would expect 2 more of those are going to disappear in the reasonably near future, because there is no real advantage from an internal Oracle standpoint to be making 4 different versions of everything when you could make essentially one version of it. So let's go to slide 28 and continue this history lesson. When I got into computing in the 1960s, applications and data and everything ran on a mainframe. We had dumb terminals. We printed everything on green bar paper. About 20 years later, due to the fact primarily that we were giving our customers lousy service, and we didn't think it was lousy service, but our customers thought it was lousy service. Managers couldn't understand why they had to wait weeks, months, in some cases years to get reports. Well, hey, we've only got so many people, we've only got one mainframe computer, we're working as fast as we can. It didn't cut it. And we pretty much dumped the mainframes and went to client server. Informix became the biggest database out there. Sybase second, Oracle third. And the applications resided on the database on the server in the IT, and where the data did, and the application code resided on Windows desktops scattered all over the world, which was a total nightmare from the standpoint of deployment and patching. It took us about 20 years to figure out how to stop that nonsense and bring the application code back into the data center. And we did that with a web browser. So we invented application servers like WebLogic, WebSphere, IIS, and brought the applications back into the data center where we could patch one copy instead of thousands of copies, and we had control over where they resided. And that has worked as a solution, database server, app server, web server, for about 20 years. 2020 will be sort of that 20-year mark. And I think about 3 years from now is when that stuff's going away from the standpoint of how we've been deploying. Because right now, what we're hearing is, let's go to slide 29, IT is not responsive to the needs of the business. It's the same thing we heard in the 1970s about the mainframes. We cost too much, we make too many mistakes, we're too inefficient, and oh, by the way, we're not meeting the needs of the business. So what we're looking at is lean manufacturing. What we're looking at is the fact that right now, when we buy a server, we don't buy a server for what we need today. We buy a server based on the fact that it's going to be weeks before it arrives. It's going to have to go into the data center. It's going to have to be racked and stacked. The operating system's got to be installed. The database has to be installed. App servers and web servers have to be configured. Firewall, LDAP, single sign-on. Months later, this thing is actually going to become operational. And when we buy it, we don't buy based on what we need on Monday at 3 o'clock in the morning. If we're in retail, we buy based on what we need in the 2 weeks around Christmas. If we are in a banking or finance operation, we might buy based on what we need for the first 2 or 3 days of each month as we do all the business analytics for the previous month. So we're buying based on what's the maximum amount of compute I could possibly need in the next 2 or 3 years. We're adding a safety margin above that, and then we put it in there, and then for the vast majority of the time, we use a small fraction of it. I find most Oracle databases running in the neighborhood of 20 to 25% of CPU capacity, even though the majority of the money went to buying the server, buying the licenses by CPU, by the way, CPUs we're not using most of the time, and support, which is also priced by the CPUs we're not using most of the time. So again, I'm going to move over a couple of slides. Let's just very quickly go to slide 31. And the most important benefit that comes from the cloud has nothing to do with the word cloud. Cloud is just jargon. And the sooner we could get rid of the word cloud, the happier we would probably be, because we could talk about what's really important. And what's really important is just-in-time inventory strategies. How can I only buy the amount of server or the amount of compute or the amount of storage that I need, acquire it just before I need it? If I find out that I don't need it anymore, I can give it back and I don't have to pay for it anymore. And that's where infrastructure as a code comes into this, because infrastructure as code is what allows you to do this just-in-time procurement. You can literally get twice as many CPUs to handle a compute problem with 60 seconds or 120 seconds lead time. We're not talking about buying something with a 3-month lead time just to get it into the data center and operational, and then with CPU capabilities that you don't need most of the time. So infrastructure as code is something that in the Oracle world, slide 32, we've really been doing for a very long time. Oracle was early to the game, and earlier than almost anybody else, just as Larry Ellison was essentially the first person to ever get into application as a service. It was Larry Ellison who personally funded the startup of a company called NetSuite, which Oracle recently purchased. But its inception, which was even before Salesforce.com and some of the others, was funded by Ellison out of his own investment firm. But infrastructure as code is something we've been doing a long time. If we go to slide 33, you can see an example of infrastructure as code as viewed by Oracle DBAs in a way that makes absolutely perfect sense. If you really have a whole bunch of databases that you want to configure, you don't go out and type /run installer and then type stuff in manually, click next, type stuff in manually, click next, get something wrong, go back. That doesn't make any sense. What you do is you do it one time and you build something that we in the Oracle world call a response file. And that response file allows us to essentially script out. Here's the name of my database, and here's the IP addresses for my Cache Fusion interconnect, and here's the size of this, and here's the size of that, and here's how to configure this. Oracle's been using response files now for at least 25 years that I can recall, and probably longer than that, but my memory isn't that good. And that's all infrastructure as code is, except rather than being infrastructure as code applied only to one product by one company, we're now applying it to storage, we're applying it to networking, we're applying it to servers, we're applying it to how much CPU we have, and we have the ability to not only dial things up, but to dial them back down. So let's go to slide 34, another example of Oracle doing infrastructure as code, a product Oracle has called SiteGuard, which if you don't know about it, is absolutely brilliant, and you need to study it and take a good look at it, because it allows for something that you pretty much can't do any other way, which is full stack failover. It will fail over your database server, your web server, your app server in a controlled way, or switch them over between your primary and your standby data center. And an example of how that's done is shown on slide 35, where I'm showing how SiteGuard is, in fact, an orchestration tool. If you've heard the phrase orchestration tool with respect to Puppet or with respect to Chef or Ansible or some of these other products, SiteGuard has been doing orchestration for quite some time and is an extraordinarily powerful product at a really, really low cost, something that you should definitely be paying attention to. So if we go to slide 36, the business case around infrastructure as code is that we reduce the cost. I install one database, I have a script, I can just go out and clone that script, and I could simultaneously install 10 databases in the following 20 minutes, and they would all be perfect. All I have to do is get the name right, get the location right, SQL plus -S, and off we go with the response file. I get much faster execution because I'm not waiting for human interaction. I'm not waiting for somebody to go get a cup of coffee or to attend a meeting. I can start off a script. I can have one script call another script. I get much faster execution, and I remove a lot of the risk. Once the code is run correctly, once I know it's going to run correctly everywhere. So I get a lot of things that are really appealing to management. Let's skip slides 37, 38, 39. You can review those on your own when you get a copy of the slide deck. And let's jump all the way over to slide 42. So I want to talk about the traditional purchasing algorithm. I mentioned it briefly before. We figure out what the largest resource we're going to need is over the next 1 to 5 years. We purchase it, we buy all the licensing to meet peak loads, we pay for it 365 days a year, 24 hours a day, whether we're using it or not. If our requirements were to go down, we're stuck with it. Oracle will not take back their licensing. Oracle will not refund your support payment. Nobody's going to buy back a used server, or at least they're not going to buy it back for anything close to what you paid for it. So there's a real advantage in looking at the ability to be flexible, to do just-in-time procurement. And what the cloud really is, when you really get away from all the hype and all the jargon, what the cloud really, really is that 4 companies have invested about $20 to $30 billion to buy massive pools of resources, massive amounts of compute, massive amounts of storage, massive amounts of networking. That's what the cloud really is. So that if you say, I'm currently running with 16 CPUs, but I want to go up to 664 CPUs, you can just go in, run a little infrastructure as code, a little statement, and magically, in a sense, have 4 times as much CPU. If you wake up tomorrow morning and you look at your database and you go, I need 4 times as much CPU, it's not going to happen. You know it's not going to happen. Everybody knows it's not going to happen without going out and buying brand new servers and going through the whole step. But if I were in this massive bucket of a cloud company, be it Oracle or Microsoft or Amazon or Google, getting 4 times as much CPU is literally, I ask for it, and 2 minutes later I have it. So let's go to slide 43. I want to show you the other thing that when I talk to management, I'm showing them and why they're going to stop buying their own servers very soon. These are in US dollars. The dense I/O compute capacity, Oracle's charging 15 cents US per CPU hour. So you have 16 CPUs in a server, take 15 cents, multiply it by 16, multiply it by 24, and that's what it costs them for a whole day. It's nothing compared to what it costs them to buy and deploy servers. Let's look at slide 44. Now we're getting into where infrastructure as code really makes the big financial difference and why this becomes so important. Let's say you go to the Amazon cloud. Now the Amazon cloud, you have to buy a fixed amount of CPU. You can't change it by the hour from the standpoint of your licensing. You can change it by the hour from the standpoint of how many CPUs you pay Amazon from a server standpoint, but not from licensing and not from the standpoint of support, and support and licensing always cost a lot more than the server. So if you went the Amazon route, which is the top one, you'd buy 16 CPUs and you'd pay for 16 CPUs, 24 hours a day. That's 384 CPU hours per day. If you use infrastructure as code, where you are dialing in, at midnight I need 2 CPUs. At 1 o'clock in the morning I need 2 CPUs. At 6 o'clock in the morning I need 2 CPUs. Oh, at 7 o'clock in the morning, people are starting to come to work. We're going to print out some reports. We'll go to 6 CPUs. And then through the business day, you increase the CPUs. You go, people leave for lunch, so between 1 o'clock or 12 noon and 1 o'clock, people are gone for lunch. We're going to stop paying for a couple of those CPU cores. We're going to save ourselves some money. You can do that with the Oracle Cloud. You not only are not paying for the hardware, but you're not paying for the licensing and you're not paying for the support. It's a pretty substantial amount of difference. And instead of being 384 CPUs that you're paying for per day, it drops it to 176. Let's go to slide 45 and you can look at the numbers. Again, these are US dollars, and these are real dollars. For the fixed, you'd be paying $21,000 in an annual cost if you went out and you just said 6 CPUs. If you do the dynamic management with infrastructure as code, the price drops by 54%. No management organization is going to look at this and go, oh, we love spending twice as much. It's not going to happen. If you assume that your company is only open 5 days a week and not 7 days a week, and you're using minimal CPUs on Saturdays and Sundays, the difference is even larger. You would drop from that $21,000 figure down to a $7,000 figure and still get all the CPU needed when you needed it. If on slide 46, and I'm going to speed this up a little bit again to keep in the interest of time, I compared a Hewlett-Packard DL580, and this was a real sale that we made to a customer, fully discounted, and compared that to doing infrastructure as code in the Oracle Cloud. The DL580 with 16 CPU cores licensed cost $317,000 over 3 years. The database as a service cost $310,000, $311,000. And you'd think to yourself, so, okay, don't tell me that for $3,000 or $6,000 US, my management's going to make a different decision. And they're not. Except that those 16 CPU cores, licenses, at about $30,000 US, would cost them $30,000 times 16. That money is not showing up in this calculation. That's money that they never have to spend if they don't buy the DL580 or the Dell or the Fujitsu or whatever else, and they just go to the cloud. That's a single check, and it's a huge amount of money, and that's where the difference is. They don't have to deal with all the network hardware. They don't have to buy Cisco routers and switches. They don't have to buy a firewall, which is over $1 million. They don't have to buy any insurance over the data center. They don't have to pay for a lot of things that otherwise they would. So even though those two prices look sort of the same over 3 years, the reality is that the savings are in excess of $1 million US over a 3-year period of time, and that's on only one server. So let's go and skip through to slide 50, and then we'll move on to the next section. So when I'm talking to management, I'm talking to them about the fact that instead of spending capital dollars, one big check today, you get a bunch of stuff, you can never return it. That CapEx, capital expenditures, become operating expenditures. You're paying every month. Every month you write a check. But the value of that check, the amount of that check goes up and down depending on what you use. Use more storage, pay for more. Delete a bunch of files, pay less. They can't do that when they buy their own SAN. You buy the SAN, you own the SAN, you already bought, you paid for it. There's no way to get any of your money back. When I go to slide 51, I look at the quality of service. Their differences are something that I think we can all understand from the standpoint of the difference that engineered systems like Exadatas have made on our lives. When architects and system admins who've never read Oracle documentation bought hardware, bought NIC cards, bought HBA cards, bought SAN switches, bought all kinds of stuff, and tried to engineer it themselves, there's probably no one on this WebEx that isn't well aware of the fact that there were some stability and performance problems. No question about it. The advantage of working in the Oracle bare metal cloud is Oracle engineered everything. It's just like an Exadata. The storage, the networking, the servers, every NIC card, every chip in the entire set has been chosen by Oracle, engineered to work together by Oracle. And there's another huge advantage. When you open an SR, Oracle has the exact same hardware you do. They go out and they can run a test case on the exact same hardware. They're not saying, okay, let's see, you're using this SAN, you're using this NIC card, you're using, you've got this patch level on something. They know exactly what you've got, and they've got the ability to replicate it, which means that patches are more likely to work properly. And if you do have to go to support, they're more likely to be able to very quickly replicate your situation. So going to slide 52, essentially what I'm saying is it's all about quality of service. It's all about total cost of ownership. And we as DBAs, knowing our jobs are not at risk, need to look at the advantages that we can now bring to the table by saying, I can go to management, and for the first time in my life as a DBA, I can show my management how to save money, how to reduce the cost of Oracle licensing. I have never, as a DBA before this, been able to say, I know how to reduce the cost of licensing from Oracle. And now, for the first time, I can have that discussion. I know how I can say, you don't have to buy an Exadata. You don't have to spend $1 million. We can just go out there and do just-in-time procurement, buy what we need, and I can get the same quality of hardware as any other Oracle engineered system. So let's go to slide 53. And I want to give you another way that you can reduce the cost of computing in an Oracle environment, make Oracle more affordable, and improve the quality of the service that you're getting. Now, this isn't going to apply to everyone, but this could apply to a lot of people. And I'm giving this to you both as a way of saving money, but also as a way of suggesting to you that there are a lot of options here, things I haven't even thought of, things other people haven't thought of yet, for using the cloud resources, this massive bucket of resources, to save money and to stop paying for very expensive licenses. I want to talk about doing disaster recovery in the cloud. So let's go to slide 54. Let me give you the business case. Every organization should have a DR site. I have never walked in on anybody and said, do you have a DR site? And they said no. And I said, do you wish you had one? Oh, yeah, but we can't afford it. So everyone understands that at some point in time, fate can strike any data centers. About 2009, 2010, was working in an office, and somebody doing cable TV out in the street took a backhoe, tearing up the street, and cut through all the cables to our building. We went 3 days with absolutely no ability to connect to any network that was outside of our building. We had to all go and work from other locations. It can happen anywhere. So it's not just about hurricanes and earthquakes and floods. If you're in Australia, it's not just about box jellyfish. There's lots of things that can strike and cause problems. So to offset this, the cost of setting up DR, those that have deployed DR often get involved in other strategies. They'll buy Oracle's active data guard licenses so that they can use that data guard standby to do queries and reporting. They'll move their backups there and offload that. They'll put their their QA and their development and some of their testing over into the DR site. A way of trying to get some value out of that huge investment. But what I want to show you is a way that you can set up DR for next to no money at all. So let's talk about that. Oracle Bare Metal Cloud allows you to subscribe to a metered service. That's the one we're using infrastructure as code. You can say, I want 2 CPUs now, I want 4 CPUs an hour from now. Then we're going to go to 16 CPUs, and at 6 o'clock this afternoon, we're going to drop it back down to 4 CPUs. You can dial in specifically the resources you need. So think about this. Suppose you had a full stack application with separate web servers, app servers, and database servers. If you're thinking about purchasing metered service, you could install all of your web servers and then shut them down. And if you're paying for CPU and you shut them down, then you're paying nothing. So you're paying for those servers while you're doing your install and while you're doing your testing. And as soon as you shut them down, you stop paying for them. You're still paying for the storage, but your web servers don't take that much storage. Go and procure some more servers for your application servers. WebLogic, JBoss, Glassfish, whatever. Install them, test them, configure them, shut them down. All you're paying for is the storage. Now go to your database. Suppose you're doing physical data guard. How much CPU do you really need to do redo apply? Redo apply is a staggeringly efficient thing. For a lot of people, 2 CPUs doing nothing but redo apply can probably keep up with a good-sized production system. For some, you may need 4, you might need 6 or 8, but for a lot of people, it's a small, or for almost everybody, it's a small fraction of what you're really using in production. If you stand up a DR site any other way, where you aren't working with metered service, you have to buy the licenses. When you do metered service, you can include the licenses in with the CPUs. So the fewer CPUs, the less you pay. The more CPUs, the more you pay. So we look at buying a metered subscription for the DR, for the database. We run it doing nothing but our redo apply. We might increase the CPU and pay a little more during a switchover for patching or migration or recovery. We might do it during a DR test or a failover, but most of the time we're paying almost nothing. So let's look at slide 56. Slide 56, this is what we typically look at. Again, a capital expenditure. The management has to write one massive check, and they've got to buy absolutely everything. Load balancers, web servers, app servers, storage, firewalls, the whole thing, and multiply by 2. If we go to slide 57, let's look at it from the standpoint of using Oracle's bare metal cloud metered service, and let's assume that my data center, my primary data center, is still on my premises. It's still inside of my company data center or colo. I buy all this stuff on the left side. I write a check. But that check is half the size of the check that I wrote on previous slide. Now, I go to slide 58. All the network hardware is being provided by the cloud provider. All its configuration, firewalls, all that stuff's been provided. I never have to pay for it. I buy my web servers and my app servers. I do my installations. I shut them down. I subscribe to my database server. I might subscribe for an OEM repository or a backup service. But essentially, everything can get shut down other than my database server doing redo apply. When I look at this from an ongoing basis on slide 59, the only thing I'm really paying for, other than a little bit for storage for app servers and web servers, about the only thing I'm really paying for on a day-to-day basis going forward is a database server that's doing redo apply and the storage for my database. And that cuts a staggering amount of money out of Oracle licensing, out of capital expenditures, and again, puts you into an environment where every single piece has been engineered by Oracle. So let me go to the last section of the 4 sections, slide 60. I want to talk about the Oracle Bare Metal Cloud. And this section of my slides only consists of 2 slides. And the reason is because this is just remarkably simple to do and to talk about. Let's go to slide 61. Oracle has a number of different cloud services available. There's Ravello, there's the Solaris Spark and Sun in the cloud, there's Exadata in the cloud. A lot of these services have real value for a lot of things. But from my perspective, the thing that probably has the most realistic value in terms of we have an application, maybe it's a couple of versions old. We have a homegrown application. We're running on Windows. Or we have some ODBC code. Or maybe we've got Cognos or Crystal Reports or whatever that stuff is that's out there. In the real world, very few companies are really running a completely clean Oracle-only stack. The Bare Metal Cloud allows you to choose your own operating system, choose your own database. You can essentially choose almost everything that you want to do and configure it and be responsible for it, just like it was in your data center. The exception being Oracle's lowering your costs very, very substantially and giving you this ability to purchase just in time, to do what Henry Ford figured out in 1908, to do what the Japanese figured out in the 1970s, which is to stop buying massive amounts of stuff that, quite frankly, you don't need most of the time. So the Bare Metal Cloud gives you the ability to do Docker containers. You can do multiple hypervisors if you want to, or, again, to run on Bare Metal.